Groovy, and I'll open up my little Groovy script in some sort of text editor. I almost said IDE. I'm going to build a little program here. It'll be a REST controller. I'll say @REST controller class greetings REST controller, and then I'll hit enter and I'll say def hi and I'll say path variable. And what I'm going to do is I'm going to build a REST endpoint here that will respond to requests. And whenever somebody makes a request, it'll say hi name. Right? That's an anonymous JSON object that I'm going to send back, and I'll make this service respond to requests at /hi /name. And so actually back here I'll just say hi. Actually, that's even better. So there we go, and there we go. So now I have a very small REST controller. This is Spring MVC, and of course I can go here. I can say Spring Run hi.groovy, and what that's going to do is it's going to look at my code and it's going to look at the imports, the types that are in the Groovy script. And it's going to use what is called an AST transform to resolve the types and then bring them in. So now I can go to /8080 /hi okay. So, and there we go. I've got a little REST service that responds. Okay. Now, of course, I know what you are thinking. That's cheating. That's not what I came here for, Josh. That's not okay. I can't deploy the Spring command line tool into production. And that's pretty fair. I agree with that. So I'm going to go ahead and build a jar, Spring jar, hi.jar, hi.groovy, right? And now I can do this. I can say java-jar, hi.jar. And what that gives me is the ability to build an app that I can easily deploy into production. In fact, my grandpa, he could deploy this, right? Because he has applets on his computer, and he can run java-jar. So if your operations, if you're unable to run this in production, you may want to consider a new career. It's okay to ask yourself these tough questions, okay? Now, here we go. Localhost 8080 /hi again, right? So there's the same service. So that's one way to get started. It's very, very, very quick, okay? So that's one way to go. But of course, I like Java, so we're going to use Java. How many of you are using Java? Okay. Well, I mean, no, there's lots of other languages. How many of you are using Scala? Okay, Scala is awesome. I'm a fan. You can use it with Spring Boot as well. How many of you use Groovy? Okay, see, there's a community. It doesn't matter. Spring doesn't care whether you use Java or Scala or Groovy or whatever, right? Okay, so I'm going to get rid of this like that, and we're going to go back to start.spring.io. This is the other way to build a new application. I like this better. This is a simple place on the web where you can get your application started very quickly. It's my favorite place besides production. There's production, Tokyo, and then start.spring.io. These are my three favorite places. Start.spring.io is a very good website. You can read it to your children. If you have uncomfortable thoughts, just go to start.spring.io and imagine the things you can build. It's comforting to know the options and potential. Okay? This is a wizard. It's a place to start your new application. You have lots of choices, though, right? So you go shopping for the kinds of technologies you want to support. I want to build a web application. Great. I want to use JPA for my persistence because I make bad life decisions. Okay, so I'll choose JPA. I'm going to use an embedded in-memory database, H2, because why not? It's a demo. Okay. I'm going to use Actuator and the remote shell for operation-centric things. And I'm going to use Timeleaf, which is my server-side view templating framework, okay? And these are just some of the choices I have here. I'll also use REST repositories. And I think that's enough. When you go over here, you have to fill out the form. It's basic stuff. I mean, this is all stuff that will be used when you generate a Maven project. So I'm going to name my service, reservation service, and I can choose a package. I can choose Maven or Gradle. So how many of you are using Maven? Okay, good. How many of you are using Gradle? Oh, right on. My kind of community. Now, this is where I get a little worried. I get a little stressed out because not all of you raised your hand. So there's a delta. There's a difference between those who raised their hands and those who didn't. Now, and again, you are among friends. I will not judge. I'm here to help. How many of you use Ant? Anybody? I give away hugs. Open source hugs. I'm here for you. Okay? So call me, come get me later. We'll do this. So you can choose whatever you like. Now, you also have a choice of packaging, right? Jar, or war? Jar or war? Okay. Now, if you are, by some crazy accident of physics, stuck in the distant past, 10, 15 years ago, unable to move forward to the present, which in the past would have been the future, then you should choose war, right? But since we are all here today, right now, in 2015, and not the distant past, unable to move forward, let's choose jar, okay? This is part of my personal philosophy of make jar, not war. Now, you have your choices. Choose what you like. Okay, we're here to support you. Okay, now, Java or Groovy? I'm going to choose Java because we already did the Groovy demo. Choose the version of Spring Boot that you want to use. I'm going to use Spring Boot 1.25. This is the stable released code, but if you want to try out some of the new features, you go here and you can see that extra things appear, cache and dev tools and so on. So whatever you want. I'm going to choose 1.25 because I want you to use features that are already available. They're stable. Okay? Okay, we've made our decisions. Let's go ahead and generate a new project. I've got a little zip file here. I'm going to open this up in my IDE. And again, we don't care what IDE you use. If you're using Spring Tool Suite or even just regular Eclipse, that's fine. If you use IntelliJ, that's fine. How many of you use Eclipse? Eclipse, oh, right on, good stuff. Very popular, very good technology. How many of you use IntelliJ? Okay, okay. Now, there's always the same guy, every country I go, who uses NetBeans. Is he here? Is he here? No? Okay, well, good. I escaped him. Good. Well, I'm going to use this. Is there somebody here? The one guy. Okay. Good. So we have a simple build here. And, ooh, that's too small. Here, let me make it bigger. Bigger. Get it? Okay, so now can you see that? Okay. Maybe a little smaller. Yeah. See, I can't even. Oh. There, it's a little bit better. Okay, so we have a regular Maven build. Okay, this is the form. You don't need that. This is a parent. This is a parent build. You don't have to use our parent build, but it is very nice because you have the Spring Boot starter parent, and then up here you have the Spring Boot dependencies dependency. And up here, we have taken common ecosystem technologies that you are very likely to use for the 80% case, and we have provided the version ranges for you, right? So that means that if you are using Spring Boot 1.2.5 and you want to update to 1.30, you get new versions and everything is taken care of for you. No pain. We have people on the Spring team who are bald, no hair, and they have done this for you, right? This is the pain that they have gone through for you. So that's one thing that's very nice. We also have these dependencies. Look at these dependencies. These are opinionated, right? So here is Spring Boot starter data JPA. This is everything you need to be productive out of the box using JPA. It has the transaction support, it has JDBC support, it has Spring's data JPA module, it has everything, right? So you don't have to worry about which version of Hibernate, which version of JPA, and which version of Spring, and the logging libraries. All of that, it's done. It's taken care of. No pain, okay? So I'm going to go ahead and comment out almost everything except for Spring Boot starter data JPA, okay? And I'm going to leave my embedded database. This is a little SQL database. It's in memory. And then I'll leave my unit testing because testing is not an option. It's a requirement, okay? Now, we have a empty class here. That's this class right here. Public static void main, okay? We have a empty unit test as well. And then we have an empty static, an empty templates, and an empty application.properties. So these are all empty. So you see, start.spring.io saved you some time, but it's not required. You don't need that place, right? It was just a little bit of code, and you could have done this if you wanted. It's nice for me because I'm on stage and I'm trying to save a few minutes, okay? Now, we're going to build a simple application. I like to build something that is of a domain that we don't have to think about. It's a simple domain. So in the West, we have an application called Open Table. It's a very simple application. You go to the phone and you do a search for a restaurant, and then you find the restaurant that you want, and then you enter the time that you want for the reservation, for the, you know, if you want to go on a dinner reservation, and then you search for the time, and then you go to the thing and you click on that and you submit, and then it sends you an email, and then you're done. And that, apparently, to people in the West, that's much faster than just calling them and saying, I will be there at 8. Now, I think it's a silly domain, so we're going to build something like that. I'll use regular old Java objects. I'm going to create a JPA entity here, @entity, okay? And it's going to be an entity that has a primary key, so I'll use @JPA entities, you know, annotations. I'll say this is an ID. It has a primary key. It's a surrogate value, so the value will increment. And I'm going to give it a field called reservation name. And this will be in the database. It'll be a column that looks like this, okay? Just like this column will be @ID, and this will be @reservation, okay? So that's our JPA entity. This is Java, of course, so we have to have some of the Java stuff. Java, a constructor, another constructor for JPA, you know, right? That's for JPA. And then that's it. So we have a JPA entity. We have our Spring Boot application annotation and public static void main. Now this annotation, I just wanted to tell you that, you know, I work on the Spring team and I think of the people on the Spring team as my friends, but sometimes we don't agree. It happens. This is common. It's how this is true of all families. And I just wanted to, I think we should have named it something else, okay? I said it, there. Now, I think it should have been named, I want to go home early. But nobody listens to me, nobody listens, and that's fine, whatever, okay? Whatever, I don't care. So, there we go. So we have our Spring Boot application, public static void main, we have an entity. We need some way to work with the data, right? We want some way to handle the creating, reading, updating, and deleting of the data. This is boring code. I don't want to write that code myself. And so the way that this is handled normally is you use a repository. A repository is a design pattern. It's an object that handles the boring creation, reading, updating, and deleting code. So I'm going to say reservation repository extends JPA repository. And it's going to be a repository that deals with entities. It'll work with entities of type reservation. And the entity has a primary key of type long. And so when I use this interface from Spring Data, I don't have to write the implementation. Spring Data will give me a bean that implements this interface for me. And this interface has nice methods like find all for sorting, save, flush, you know, delete, find by ID. And there's even methods here for paging and sorting and so on. Now, Spring Data is a big project. There are other modules that you can use. This is for JPA, but of course there's MongoDB and Cassandra and Couchbase and React and Neo4j and GMFire or Geode. Lots of different technologies, Redis, I mean, all sorts of things, right? So I'm just using JPA here, but it's very common. Another thing that's really nice is that by convention, I can create a finder method. So I can say, find me all the reservations where the reservation name attribute equals RN. Okay? By convention, this will be a query that looks like this. Select all from reservations where reservation name equals RN. Okay? And of course, I can override this. I can say add query like that. But that couples me, it ties me to the query language. For Neo4j, I would use Cypher. For Cassandra, I'd use CQL. For JPA, I would use JPAQL or BSON for Mongo. But I don't want to do that, so I'm going to leave that out. Now, I'm going to define an object that works with that data. I want to save some data to the database and prove that things are working. So I'm going to create my first Java bean. How many of you are using XML for Spring? Okay. Wow. Okay. How many of you are using Java configuration? I love it. It's so cool. So Java configuration is a way of telling Spring which beans you want to manage, right? Spring does not care how you tell it which beans to manage. It can do it from the XML. It can do it from via automatic convention with annotations on the components. It can do it via Java config producer method. Okay, so here I'm going to create a bean of type command line runner. Whoops. There you go. And a command line runner in Java, in Spring Boot, in fact, has a very simple contract. It's a callback interface. So when Spring Boot starts up and you want to run some code that lives at the same time or executes at the same time as your public static void main, you put the logic in here. But it's a regular Spring Bean, so it can have dependencies and you can inject things and all that. It's like initializing Bean. It's like the interface initializing Bean, but it also gives you the public static void main string arguments. So this. Okay. Now, how many of you are using Java 8? Oh, good. Okay, so lambdas. How many of you are playing with lambdas? Lambdas are a really new feature. They're only the modern languages have lambdas. Languages like COBOL and C, Smalltalk, Lisp, Perl, PHP, F#, C#, Python, Ruby, JavaScript, Haskell. Only those modern languages from the last 50 years have lambdas. So it makes me very happy that Java finally has lambdas, right? It's a little embarrassing that C++, a language whose governing body meets only once every few years, they got lambdas before we did. But okay, whatever. At least we have them now, and that's good, right? So the nice thing about lambdas is that I can just take these interfaces. This interface has one method, right? So I can express this method as a lambda. I don't need to create a full object. So I can do this. I can say replace with lambda, right? So that one method, I can write it like that, and that's very, very convenient. And then I can also use Spring's dependency injection. So here I'm defining a bean, and I'm saying, Spring, give me a dependency repository. There we go. And I'm going to create some data. I'm going to say arrays and list. So I'll say Rod and Jürgen and I don't know, Rob and Dave. Actually, that's Dr. Dave and Phil. And then I'll split some names. Okay, so I'm going to save these names in the database. So I'm going to say for every name in that database, let's create a record in the database in that list. So here we go. New reservation X. Great. And then I'll say repository dot find all. And that'll give me a collection back. And now I can call the for each method and print out everything. I can do this. This is one way to do it. I can say system.out.println x. But if you think about what I'm doing, that's a bit wasteful. All I'm trying to do is to tell Java to call the println method every time it has a new object. So I can use method references. Another very nice feature that only modern languages from the last 50 years have. Okay. Another nice thing, I'm going to just prove that everything's working. So I'll say repository .find by reservation name, and I'll say find the one called Rod, and then iterate through all that. Okay. Here we are, print line. Good. And now we should be able to run it. So I'm going to run the code, and while that's running, I'll drink some of this delicious, delicious tea. Okay. Oh, fail. Okay, hold on. Awkward. Sorry. Doesn't usually happen, but you know, I have been awake for like 2 days. So here we go. So there's the data, and it worked. Of course it worked, right? Come on, it was a demo. I wasn't going to fail. But that's not really what I wanted to show you. Instead, let's talk about this. So this is the ASCII artwork for Spring Boot. Now, this ASCII artwork I think is very well done. People have said all around the world, they said they love the ASCII artwork. It's a great improvement to the Spring ecosystem. And I think that if you're trying to communicate with the other communities, good quality ASCII artwork is very important. We have people on the Spring team that are doctors. They, in their previous careers, in their previous lives, they worked with nuclear physics. They concerned themselves with the very stars in the very heavens above us. Star stuff, my friends. The things of the universe themselves. And now, one day, they got a GitHub issue or a Jira issue saying, we need good ASCII artwork. And look at it, it's gorgeous, beautiful. Now, I'm a fan, and people always, they say that they love it, and I love it. I wanted to take issue, I wanted to complain about one little feature inside of IntelliJ that I don't even know and understand why it's here. There's this new feature, it's a feature in IntelliJ, and it says, hide the banner. That is the dumbest thing I've ever seen. Why are you here? Whatever. So, anyway, don't ever click that button, it's dumb. So moving on. Anyway, so it's 2015, and of course we've got data, and it's talking to the database, that's fine. But a modern application today, eventually, they say an application of sufficient complexity eventually sends email. I say that an application today eventually has a REST API. So I'm going to go back to my build, and I'll go bring in Spring Boot Starter Web. Here we go. And I'm going to go back to demo application, and I'm going to build a little REST controller. I'll say REST controller class reservation REST controller. And I'm going to do something that you should never, ever do, not even when you're all alone at home by yourself and no one is looking, okay? Never. I'm going to use field injection. Every time you do this, a unit test will die, a terrible death. So you should never do that. You should use constructors. But I have very little space on my screen, my friends, so that's why I'm doing it, okay? Here we go. We're going to say reservations. And I'll say collection of reservation. Here we go. And I'll say return this .reservation repository .find all. There we go. So now I've got a simple REST API, and I'm going to start it up. Drink some more tea. Okay. Localhost 80/reservations. So there's my data, right? We knew that was going to work. That's the REST API. Not bad for a little bit of work. I mean, okay. But to be honest with you, that's way more work than we needed to do, right? If you think about what we're trying to do here, I'm trying to take my data from my database and expose it as REST verbs. I want to be able to create, read, update, and delete the data from my database. Well, naturally, my repository already knows how to do that. So it's a natural extension to be able to say, let's map that to my repository. I'm going to use Spring Data REST here. Here we are. And I'll go back to the demo application. I'm going to annotate this with @REST repository, or repository REST resource. And I'm going to map the endpoint here. I'm going to say REST resource path by name. And I'll annotate the attribute as a parameter. Okay. There we go. And I'm going to restart my application. And I'll let the machine do the work for me. Actually, whoops, I don't need this also. I killed it. Let me kill this. This is wasted code, so I don't need that. There we go. Much better. So good. So good. So there's my new API. Much nicer, right? This is the same data. There's the information as before. But we have links. These links tell us what we can do with the data that we're looking at. It provides a sort of self-describing API. This is an implementation of the design pattern, HotEOS. Hypermedia as the engine of application state. It's the idea that every REST resource should have enough information so that I can use the REST resource without any knowledge that I had before, right? I can discover everything. It's like a menu where you can choose what to do. We use this all the time in HTML. We say link rel equals text CSS, source equals x.css, like that. That is a link to style sheets that the browser client can use to figure out what to do, right? The browser says, oh, well, what is the relevance of this style sheet? Well, it's used to style the document. It's metadata that the browser HTTP client uses to work with other resources. We have the same thing here. It says, oh, look, you have a list of data. In fact, if you go to /, you have a menu. You have a list of reservations here. You can click on that, and it says, well, you're here. The relevance is that if you want to get back to this URL, you go to self, and this link is templated, right? It has parameters. So I can say, let's use some of the parameters. Page equals 1, and size equals 1. Well, look, there's only one piece of data, right? I get paging and sorting for free. I even get metadata. I get the links here. It says, oh, if you want to go to the next page or to the previous page, here are the links, right? So these are smart APIs. These are, you can discover what to do, and it makes it easier to navigate them when you're developing, okay? This promotes long-lived services. If you think about what we're trying to do with an API, I may want to change the URLs, the structure of my REST services, but I can do that now because the client will only consume these links, right? That's the contract between the client and the service. The URL is unimportant. I can change the URL and things don't break. This makes it so you can have stable APIs over years, not just months, right? This is the final form of how to build smart HTTP-based systems, right? Dr. Leonard Richardson talks about this a lot. It's the third level of a mature REST API. We're using, by the way, an encoding called HAL, right? HAL, H-A-L, Hypertext Application Language. This style of JSON is a standard. It's a community standard. People are using it everywhere, okay? Now, that's very good. And also, of course, I have my search endpoint, right? I can go here and it says search, reservation search. And there's my find by reservation name endpoint, and it says search by name. So I'm going to say search by name equals Rod. Oops, equals RN equals Rod. And it found the one record for Rod. So my custom finder methods are automatically exposed as well. This is very, very powerful. You can move quickly. Okay, now this wouldn't be much of a demo if all I did was create a REST API that talked to a database. Even Node.js programmers can do that, right? That's not the big thing, right? Instead, let's do everything. So the next thing I'm going to do is build a server-side generated HTML page, something very simple. It wouldn't be much of a demo if I didn't, right? So I'm going to use just old-style, classic Spring MVC, okay? Anybody here use Spring MVC? Okay, it's a thing. It'll be okay. So class, reservation, MVC controller. And I'm going to inject my repository. I'll say reservation repository. And I'm going to create a URL this is a simple, silly URL. I would never use this in actual production in real life ever. I mean, you know. Okay, there we go. So that's my silly. Now, again, you can use whatever you want, but you know, have some shame. Here we go. Now it's a simple MVC controller, so somebody's going to call the endpoint, and I'm going to add an attribute. I'll say reservations, and I'm going to get all the data from my repository like before, and then I'm going to render a template that will load the data. And the template has to be rendered by something, right? I have many options for template rendering, but I'm going to use Timeleaf. Okay, this is Timeleaf right there. That's a templating technology. There are many other ones. There's Groovy server pages. There's Velocity. There's FreeMarker. There's Mustache. In Spring Framework 4.2, there's even isomorphic views like React.js. You can actually support that kind of stuff. It doesn't matter. We don't care. Use whatever you want, right? I like Timeleaf because it's a natural templating framework. So the markup is faithful to the structure of the document. It means I can open it up in my browser or my design tool and it'll look correct, right? So this is great because what it does is it solves that problem. Let me see, MISC. It solves that problem that a lot of people have. Maybe this has happened to you, I don't know. Have you ever given your designers a JSP page or something like that, a JSP page, and then they leave a bag of poop that's on fire in front of your desk? You know what I'm talking about? No? Has that happened? No? Oh. Well, so you don't use JSP then. So I've had that happen a lot. Have you ever wondered why the design people look at you really angrily when you walk in? Right? When you come into the office, you're like, "Hey, George," you know, and then, yeah, that's because you give them JSP, and they hate JSP. It makes them sad. Here, okay. So avoid. There are things on the sidewalk that are more useful for rendering HTML than JSP. You can use JSP if you want, but don't. It's 2015. Do better, okay? So, what do I got? Bootiful microservices. I'm going to cheat here. We don't have a lot of time after all. And I am all about cheating when I can. Source, main, resources, templates, application. Okay, PB copy. Okay. So now I go back here, I'm going to paste, and you can see this is a regular old time leaf document. It has attributes and so on. It's XHTML and that kind of stuff. And it's like Angular on the server side. For each reservation R in the model attribute, I'm going to print out this data. Okay? And so here's the reservations attribute, here's the data, and this is the template that's going to be used. And Spring Boot is going to apply a view resolver, and it's going to use the algorithm in the view resolver to find the template. So it'll be, source main resources templates X, and X is reservations.html, and you can see that's what I've done here. Source main resources templates reservations.html. Okay, now if I run this, you'll see the application's up and running. Oh, that's so good. So good, there's this. Awkward. Oh, wait, no, it's the silly one. There you go. Oh. Okay. Of course it worked. So there's my data, right? So now I have a simple template, not a big deal, and I've got the REST API, that's fine. There are other ways to build user interfaces, of course, right? So one option might be to use something called Vaadin. I don't know if you've ever used did I check that one? No, I didn't. If you had this, you could use that as well. The point is, we've so far done a lot. We've built an application that has a REST API, but this isn't really why we're here. I mean, again, I didn't invite you here to come watch me build something very quickly with features, right? We can all build features pretty quickly. Let's just be very modest. People say that about me. They say, Josh, you're the most modest person I've ever met ever in all of the history of people that have ever been modest. And they say, you must know what you're talking about, and so clearly Spring Boot is easily just 20 or 30 times better than everything I've ever seen. And I agree with you, right? Let's just say that. Let's just say that I'm very modest and that Spring Boot is the best times a lot, okay? But the reason it's the best is not because you can build features, because you can build features with other languages too, right? Like Rails and Node and PHP. So, whatever, right? You can do that. What we care about is going to production, and that's where this is different. Spring Boot wants you to go to production. We're trying to make it easy to go to production. So you go to pom.xml, and I'm going to bring in some features. I'm going to bring in the actuator here, okay? And I'm going to bring in the remote shell. So let's get rid of that, and get rid of this. Oops. And there we go. So I've just brought in two libraries right there. And it's the actuator and the remote shell. These are frameworks, these are technologies that are designed to help you build production-ready systems, okay? So I'm going to restart this now, having made no changes. There's a lot of things that frustrate our ability to go to production, things that you're going to need when you go to an operational application, right? I need insight, I need the ability to see what my application is doing. So if I go here and I make requests, lots of requests, and I go to /reservations.php, and I make more requests like that, lots of requests. I'm Command R, very, very fast. Okay, and then I go to / whatever. And now I can go to metrics, and metrics comes with the actuator framework. Okay, this shows me how much memory I have in the application, how much is free, how many processors I've got, the uptime, the classes that have been loaded. And even better, it shows me that I made 49 requests to reservations.php, and I got a status code of 200, right? It shows me that I made 14 requests to /reservations, and again, I got a status code of 200. So this is a very nice way to see what the application is doing. I can, of course, also create custom semantic metrics like customer checked out or the shopping cart was paid for or whatever. You can also create those. If I want a deeper look, I can go to the trace endpoint. The trace endpoint is this. It shows, oh look, somebody made a request at this time with this HTTP verb at this endpoint with these headers, right? This is by default just the last 100 requests that have been made into the application. I can also go to env. Env will show me my Java properties as well as my environment variables, right? So here's all my environment variables. But notice that important secret-y things like my access key, they're hidden, right? My key is hidden. My secret is hidden. What else? password is hidden, right? So it's very smart, but it also gives you the ability to understand what your application is doing, what the configuration for the application is. I have an info endpoint. This endpoint is empty. There's nothing there, right? Info is customizable. And what a lot of people do is they put Maven resource filtering. They have Maven write a value into a property file, and then that value shows up here. One good value that you might put there is the git commit ID. So if you're doing continuous delivery, you want to know which version of the code triggered the build that's in production. You can do that with that. You can also put the name of the project and so on, right? There's also mappings. Mappings shows you the HTTP endpoints that are available outside, right? So this is very good if you're trying to do auditing, if you're trying to kind of understand the exposed surface area of your application. So it says, look, I've got I've got a endpoint here called reservation/ID or repository ID property, and it responds only to HTTP GET, and it produces this JSON, these content types, and so on. So all of that information is here, and it tells me that the Spring Bean that does that is this one right here, right? So that's very good for security, from an auditing perspective. If I want to know what's happening, these endpoints are very helpful. What else? If I want to know what beans Spring has created for me, I go to /beans. And beans shows me all the relationships in my objects, how they're wired together. So here's my reservations MVC controller. And the MVC controller lives in this Java class, and it has this bean dependency. So now I understand which objects are wired together and how, right? My favorite endpoint is, of course, health, right? But this health is it's a good way to understand the status, the health of the system. Spring Boot can tell me a lot about the health of my system automatically, but some things are specific to my application naturally, right? So I want to override what this does, right? So before we do that, we're going to come back. There's other ways to look at this information. I'm using a REST endpoint, but there are other ways to get this information. Spring Boot supports, in Spring Boot 1.3, the new version of Spring Boot, we support writing out to OpenTSDB, to Graphite, and indeed to Etsy, and using the Etsy protocol. So Etsy can be used to write out to anything else, right? Etsy is a protocol that other metrics, shipping, and aggregation systems use. So we support automatically. You can write all these things out to those different systems instead of just REST. If you want to use the defaults, you can also do that. So you remember that I had 2 jars, right? By default, Spring Boot will also export everything to JMX. So this is the Java 8 JConsole thing, okay? I'm going to go down to here. I'll say mbean server. There we go. And I'll say mbean browser. And I'll go down to this JMX endpoint. I can click on it. There we go. Endpoint. And there's my metrics, right? There's the data from the metrics as well. Right? All that stuff is available from JMX. I also have another option. There's the remote shell. So remember that I had in my build Spring Boot starter remote shell. The remote shell is a great way to look at the state of the system. It uses SSH and it needs security. I have not used Spring Security here. If I used Spring Security, then I could automatically log in with the username and password from Spring Security, from any valid identity provider. So OpenID, LDAP, Active Directory, OAuth, PAM, Kerberos, whatever you want. But since I did not, I have a default username and a default password, and the default user is called user, and the password is printed here in the console. Okay, so I'm going to go there, and I'll say SSH -P 2000 user at 127.0.0.1, enter the password. Again, very important, very good quality ASCII artwork. Now, it's calming in a production situation when you're trying to triage the system. To have that there, it calms the nerves. You can ask for help. You can say, oh, help, great. And you can say, oh, system, prop ls, there's my environment. I can say, show me the metrics. And there's the metrics. And notice how that's animated. It's live. I'm not touching the keyboard or anything. The numbers are updating, right? That's all there. I can also do other things that you couldn't do elsewhere. I can say, show me the compiled hierarchy for reservation repository. So I'll say Java type demo.reservation repository, and it shows me that this is a type like that. Or I can do Java type java.lang.string. There you go. It shows me that. Whatever. I can lots of different endpoints here. You can actually also look at the endpoints. You can say endpoint list. There you go. Endpoint invoke, and I'll show the metrics again. Metrics endpoint. There's all that data as well. My favorite perspective in here is called dashboard. So I'm typing in dashboard, okay? And when I do that, I get Java top, which shows you the memory of the process, of the actual application. It shows you all the threads that are running. And then on the bottom, you have the memory pools. And remember, Twitter moved from Rails to the JVM specifically because of this ability to see what the engine is doing. Java is a very powerful platform. Anything you can do to show you more information about the system gives you power, right? So we're going to take advantage of that here. I can see all the information there. Now then, these are 3 ways that we've got out of the box for consuming different types of information. I want to customize that health endpoint. Do you remember the health endpoint that we had? The health endpoint was kind of boring, right? It doesn't show me a lot besides the global health attribute, up. It says the system is up. But I want to change that so it has a custom business-specific or a semantic health endpoint. Additionally, I want to move those health endpoints to some other place so that they're not in my way and I can secure them if I need to. So to do that, I'm going to first use the power of properties. There are many different ways to extend or change a Spring Boot application. But Spring Boot makes it dead simple. Spring Boot makes it dead simple to configure a lot of different things using properties. So I'm going to say management. Management.context path. And by the way, this auto-configure, this auto-completion, this works in STS, our Spring Tool Suite, the Eclipse distribution that we provide. It works in IntelliJ 14, and yes, for that one guy, it works in NetBeans. So I'm going to say management.context path /admin. So that means health and beans and metrics will all be under /admin. I can do things like change the port. I can say server port is 8000 instead, right? I also want to change what is shown. So I'm going to say enable the health endpoint, and I'm going to say it's not sensitive. So sensitive is false. I want to show everything because what's happening is that Spring Boot it automatically sees information about my application, like the database that it's connecting to and the file system. So it sees the information about the application, and it can tell us that, but it's keeping it hidden for security reasons. So I'm going to tell it to not hide everything. I also want to add my own custom health indicator. So what I'll do is I'll say bean at health indicator, and you can see that Spring Boot has a lot of health indicators for other things: MongoDB, RabbitMQ, Redis, Solr, etc. If I'm using Spring Boot 1.3, there's also Java Mail and Elasticsearch and in Java and JMX and JMS. I mean, lots of different health indicators out of the box. So I'm going to create my own though. I'm going to say custom health indicator, and I'm going to say return new health indicator. And again, same as before, it's a lambda, right? So it's a very simple contract. When somebody asks for the health, my health indicator has to return the health, and I can say, oh, health.status, or health up, or down, or status, or out of service, right? Lots of options. I'm going to just do a custom status. I'll say .build, okay, and there you go. There's my custom health indicator, and I'm going to replace it with a lambda because it's cleaner, and I'm going to run the application again. So there we go. So this will no longer work, right? Remember, I moved the application to port 8000, so that's interesting, right? We see port 8000. This won't work either, right? Because I moved everything underneath admin. And I've now shown the automatic endpoints, the the disk space and the database connection pool. This is the connection pool that Spring Boot set up for my data source. It added a validation query, select one from dual, right? This is the result of that validation query. So now I get insight into how the database connection itself is doing. And of course my file system, I have a file system, so there's information about that. And there's my custom one as well. So now I've used the defaults, but I get interesting behavior by contributing objects. The way that this is, the way I use those properties here is nice, but Spring Boot is also very, very easy to deploy and manage, right? So I'm going to go here, go back to my application, CD, downloads, reservation service, and I'm going to do Maven clean install. Okay, and oh, did you hear that? Oh, that was so good. I'm going to do Maven clean install, and when I go to the target directory, you'll see I have my fat jar there. It's a big jar, 39 megabytes, right? It contains everything that I need to be able to run the application. So of course I can do Java-jar, reservation, snapshot, whatever. And notice that even the colors on the console are taken care of for you, right? We have put in default logging so that the output is not too much and the colors are nice and it's readable. You can change everything, of course, but even this is something we thought about. We tried to make it as clean as possible. So that's up and running. But what if I want to change? What if I want to change some of the defaults? Maybe I want the application to live on server.port equals 8010. So recall that here it says server port is 8000. Here it says 810, right? So I do that. And now it's going to start the application on that port, right? And what I'm trying to do is I'm trying to use the defaults, but I can change it when I actually have to run it, right? So now localhost 8010, right? What if I don't want to do -d arguments? I want to do a property file. I can say touch application.properties. That's one way to go, right? Or, even better, we can use application.yaml. So I can say server, new line, space, port, 8020. And I'll say application.yaml. Okay? So cat application.yaml, java-jar, reservation.jar. And then, of course, this will no longer work, right? That's going to fail. But now I go to 8020, and there's my application as well, right? Or I can just delete that, yep. And I can say export server underscore port equals 8030, java-jar, reservation.jar. And what this is letting me do is it's converging. It's taking all these different inputs and canonicalizing them. It's making them common so that it's the same mechanism. And this lets me do 12-factor style configuration, right? I can create one binary and move it from dev, QA, and production and just change the environment, just the properties. And it's not even very hard. No extra code required, right? So now this application is on what, port 8030? There you go, right? So this gives you the ability to build services, to build applications, and to get them up and running and manage them very quickly. We have used these properties to change things related to Spring, of course, but also things related to the application itself, the server. And the reason we have done this is because we have seen too often that people take, for example, Tomcat. How many of you are using Tomcat? Anybody? Nobody? No one. Well, Tomcat's pretty cool. I'm a fan. Okay. Tomcat is it's most of the market for application servers in Java are using Tomcat. This is what I have seen all around the world. And in fact, there are lots of from the competition even. They'll even say, yeah, if you're not looking at Java application servers, I mean, Java application servers are like 40% combined. Most of the rest of that is Tomcat. So Tomcat's very popular, and I like Tomcat. But I think a lot of people use Tomcat because they know how to operationalize it. They know how to manage it in production, right? It has a startup script and a stop script, and there's monitoring tools around that. So I've seen applications where they build batch code. They build batch processing or integration code, and they put it in a Tomcat web app, and then deploy that. There's no web endpoint. There's no web endpoint at all. It's just batch. And the reason they do that is because they want to have a consistent way to service and deploy and manage applications. Well, this is much simpler. I think you can agree, right? Public static void main is very, very simple. The other thing that I've seen is that people take things like SSL configuration or gzip compression. And these are things that you have to configure in the container, in the application server. You don't configure that in your web application normally. And they put it in server.xml, and then they check in the source code for server.xml into their application. Well, that's disgusting, right? Now I've got the configuration for both my application and my application itself living together. And I understand why. It's because they want to make sure that when they certify the build and they certify the container, that it's the same one that gets deployed all the way to production. They don't want to have to worry about operations having the right config, so they make it all together. I've seen environments where they check in Tomcat itself into Git, right? Like, that's not supposed to happen. That tells me that there's a smell. There's something wrong here. These concerns live together, and with Spring Boot, you can address them in the same way. The same tools, the same API. Now, all of this is working thanks to the magic of something called Spring.Factories. So Spring.Factories is a text file that's in the meta-inf directory. Okay? It has a list of Java configuration classes. It says enable auto configuration equals, and then there's rabbit autoconfig and batch and JPA and REST and so on. So you go to rabbit autoconfig, and you can see, open source, that this Java configuration class is a regular Java configuration class, and it defines objects for you, like your connection factory. So if you're using RabbitMQ, there's only so many different ways to create a Rabbit connection factory. This is going to do a good job for you. And we make these very dynamic. So here we're saying create a Java configuration class, but only if this type is on the class path. If it's not there, then don't bother. I don't want to create a Rabbit connection factory if the RabbitMQ library is not on the class path. Same thing here. I want to create a Rabbit template, but only if the user, that's you or me, hasn't created one himself or herself, right? So this is dynamic. I can build things that default to something useful, but then they back off. They do something different if you override them. This allows you, and by the way, you can do the same thing in your services in your organization. Imagine going to start.spring.io. You can get the code for start.spring.io. It's on GitHub. Go to github.com, spring-io, it's called initializer, right? This code is right there. That's the code for start.spring.io. So you can take that, add your own starter dependencies like I have shown you, put in your own auto configuration, and then somebody in your organization, they go to that website, click generate, and now they can build a new service. Instead of going to a wiki page with 20 different steps to have new security, if you want your services to be consistent, you want to have the right security, you want to have the right Spring MVC configurations or whatever, put it in an auto config, and then give people this start.spring.io. This is how you achieve consistency in your services, right? By building on top of the component model that Spring Boot gives you. Now, I have to go. I'm sorry for running a little long. When we come back in an hour, I want to talk to you about something called Spring Cloud. This builds on top of Spring Boot, right? We have used Spring Boot to build one application very quickly, and I've done some simple things. And you see that it's geared for production. When we go to Spring Cloud, we can build lots of services and manage that complexity. All right, thank you very much for your time. I appreciate it, and I'll see you soon. What do you guys think, by the way? Yes? No? Yeah.
もし質問ある方いらっしゃいますかね。その場合一人いいですね。じゃあもしある方は前に来ていただいて直接聞いていただけです。ではじゃあセッション終わりいたします。ありがとうございました。
Josh, yes, sir. Sorry? Hello, sir. Nice to meet you. Yeah, I know.
Details are very important in operation.
I love that people build important things around me. It's trash. Sorry. Where did I put it?
The money is important.
You can have it.
Yeah, we don't need your name, Carl.
Oh, but-
we know you. So
Yeah, but-
that's fine.
You know, I am.
You brought it, right?
I don't want to offend my friend. Sir? Thank you, my friend. It's good to meet you. Do you want a sticker? Yes, sir. No, spring, baby. Spring for the win. I mean, you can have it. These are more fun. Put it in your laptop. It's great to meet you. I hope we can talk some more, and hopefully this will help. Come to the next session? Okay, very good to meet you. Thank you. Sir. Cool.
Okay. So I have to go. So
Oh, no.
I will see you on
Tuesday.
Yeah.
Thank you, man.
September.
You're a hero.
Yeah. Okay.
My hero. Cheers.
Okay. Bye.
I'm sorry. Oh, yeah. Can I bring? Is that mine or yours? I'm sorry I ran so long. Okay, good. Where's the trash? I'm really sorry. I'm so sorry. I'm sorry. Good luck.
Thank you.
Thank you, my friend. Yes, sir. All right, trash.